Yeah. I work at Rapid7, and today I'm going to talk about two initiatives that we have. Wait for it. Okay. So there's two initiatives we have I'm going to talk about. Hello? Yeah? You guys ready? Ready for this? Okay. So two initiatives, Project Sonar as well as Project Recog here. So Project Sonar is an internet scanning project, like scanning all the things. And Project Recog is an open source asset and service identification model, which is based on the data collected from the Sonar project. Version of this talk was given at Sector this year by two of my colleagues, Ross Barrett and Ryan Papa. But today it is given by me. This here is a faded version of what was once a vibrant Rapid7 orange. But it was actually before I started working there, which was about a year ago. Before that, I worked at the Citizen Lab at the University of Toronto, where they also know a few things about scanning the internet. I was a data wrangler there, still a technical advisor. And they do a lot of research into internet censorship and state-sponsored malware attacks. And I'm aware of at least one project there that has actually used the Sonar data. Thanks. All right. Piped down. Nice. Nicely done. All right. So yeah. Sonar, as I said, it's initiative Rapid7 launched a little over a year ago in September 2013. And so what is it? It's an internet-wide scanning project, as I mentioned. It's the labs team at Rapid7 that does it, but also it's a community effort, which is a really important part of this. So the idea is to identify and raise awareness about misconfigurations and just other issues in the general security space. To allow users to find potential security threats and other potential issues that could be used by attackers. It's been continuously running since we launched it just over a year ago. Yeah, so really it's a community effort to improve security through the active analysis of public networks. So we run scans across public internet-facing systems, organize the results, and share the data back to the information security community. And yes, so the Rapid7 Labs team is headed up by HD Moore. Together we advocate this internet-wide analysis as a practical tool for security practitioners. The idea, like, to meaningfully improve your network security. So the end goal is to enable the security community to start sharing data and working together so we can more easily identify and tackle all these problems that are confronting the industry. And this isn't intended just to work for security researchers. It's a tool set that all security professionals can use to become their own researcher and scan all the things or contribute to a shared analysis. So like all of the security research that Rapid7 conducts and publishes, Project Sonar is designed to help organizations and individuals understand how they're at risk and take the necessary steps to protect themselves. So it's, part of a commitment to make our customers, but as well the broader community, more secure. So collaboration is key here. We want to enable the security community to collaborate more on this, start sharing data, and work together on the things that we're all facing. So anyone here, like any of you, can download the data, work with it, and reshare it with everyone else. And that's how we want this to work. It's the best way to advocate and teach people about what is out there. So it's all about sharing with the wider community. So that's the why we're doing this. What is it? What are we actually collecting here? So among other things, we collect all the SSL certificates visible on public IPv4 HTTPS web servers, so port 443. This data can be used to detect changes such as malicious replacement of certificates or reveal the revocation of a compromised previous certificate. This data is complementary to the EFF's SSL Observatory project, if you've heard about that. Other purposes for this include the detection of insecurely reused or still actively used revoked certs. In addition, with the Sonar data, one can see all IP addresses or services that claim to represent a particular domain. So this in turn can be used for asset identification and detection of malicious certificate usage. So also, the certificate fields can be used for software and hardware identification in specific situations. And this SSL work is being expanded to encompass non-HTTP services as well, like Start TLS-enabled SMTP or IMAP servers, that kind of thing. So as well as the SSL stuff, we collect the HTML content of the index page, so just the root of all IPv4 web servers, again, so just port 80. Similar to what search engines do, but we just grab the initial root page. We don't crawl the site any further. One of the potential uses of this data set is the identification of compromised web servers and like injected malicious snippets, HTML snippets such as like iframes or JavaScript, ActionScript, exploit kits. So during the course of this collection, this research, we found several instances of these iframes pointing to exploit kits that try to infect client computers accessing the web pages. We also use this data to identify vulnerable embedded devices through fingerprinting the content and the headers of the HTTP response. And what else? So DNS records. We also gather the reverse DNS records for all IPv4 addresses. And this enables organizational asset discovery and can help identify misconfigurations and potential DNS hijacking attempts as well. Sonar uses the domain names gathered from the above processes as well as certain TLD zone files to conduct DNS any record requests, and is also useful for asset discovery, as well as for the identification of phishing portals and new malicious domains matching algorithmic patterns. And finally, well, last but not least, is the UDP services that are scanned as part of this project. So this includes NetBIOS, DNS, NTP, IPMI, NatPMP, BACnet, SIP, SNMP, MDNS, and a bunch of others as well. And we use this data to identify large-scale misconfigurations and vulnerabilities in the consumer, enterprise, and critical infrastructure systems that are out there. So we've used this information to publish advisories, present them to vendors to help them improve their own overall software security. For example, Rapid7 did an advisory on IPMI last year. There was an NTP one a few months ago. And most recently, I think it was about a month ago, there was an advisory about NatPMP. And we keep adding things every day, and again, share the information back out to everyone out there. And again, you can download this information and do what you need or want to do with it. So that's the why and the what. Where can you get this? Main site is scans.io, also sonar.labs.rapid7. So there's all the data is available here. Scans.io is a partnership with the University of Michigan. It's where we share everything. So this is where you get the SSL certs, DNS reversing, the root pages. So it's downloadable. There's a blog post by H.D. Moore on Rapid7 that details some of the data and talks about useful tools to use while you're working with it and processing it. So that's Scans.io. The Sonar page has the mandate for the project, like what we do, how we do it, and how you can opt out of our probes, even though we're not really doing anything too bad. But you can say no thanks if you want. And so the other legal type stuff like that. And also information about what we have and what we want to do moving forward with this project. And one caveat I can mention is that since we're scanning all the things, the data sets can be quite large. So HD's blog post is helpful for this. Tools like PBZip2 or PIGS that exploits multiple cores to speed up decompression operations on these zipped up data set files. All right, so that's Sonar. That's the basic, the raw data collection. the foundation for Project Recog, which is what I'm going to talk about now. So we took Sonar and moved forward toward this. Now this is a bit from the Rapid7 perspective, because this is where I work now, and the deck I've got was from the sponsorship track at Sector. But most of you probably know about Metasploit, right? It's an open source project, the Metasploit framework, that has a commercial product built on top of it. It's developed by Rapid7. And kind of on the other hand, slightly different model, there's Nexpose, which is a vulnerability management tool, commercial product, which has a free version that you can download and trial and use. So for both of these tools, a common issue that we've really struggled with, and it's not just us, I know, like many others in the community continue to struggle with, is the uniform identification of devices on the network. We see a lot of things when we scan, right? Networks are just jammed with open ports, and the purpose of these isn't always known. So we see an open port, but what service or protocol or actual device is running on there? So what's meant to happen here is go from that vague understanding of what's happening in the situation where we have okay, so we pinged it, there's an open port, maybe some kind of SYNAC handshake type thing going on. Maybe there was a banner there, and then you get like CSI enhance, and you know, this is actual Sonar, not some TV bullshit, but it gives us maybe an idea of the shape of something that's out there, slightly better understanding. And then the next step up here is it's a higher quality side scan sonar image of a sunken ship, something we can actually recognize, right? So there's more actionable information. So yeah, I think it's clear. The basic idea here, going from the basic scan with potentially many unexplained ports or protocols and services to an increasingly better understanding until we can positively identify specific endpoints, maybe given enough context about them. So Sonar provides a lot of data, and we want to encode our knowledge of that environment to leverage the data, right? So the raw data in Sonar is terabytes of the SSL certs, banners, DNS records, updated weekly or even daily. And there's a lot of churn around this stuff. Like, it just changes all the time. Just different configurations, things moving around, people asking us not to scan them. But we want to build on the raw data to get the real understanding. So as of a month or two ago, this data, this Project Recog data, is backing all of Metasploit's and Nexpose's device fingerprinting. So a major theme here is that it's harmonized, right? We want this to be useful across projects. I'll talk about the GitHub information later, but it's open source. You know, other people can contribute to it. So quick example here. It's a code snippet. It's what one of the fingerprint files looks like. So it's an XML file in the Recog repo. This example in particular, hopefully you can kind of see it. It's a Pro FTP daemon running on a Linksys wireless access point. So hopefully this chunk of XML isn't too off-putting. So there's some XML, some regular expression stuff going on in there. There's the example tag, which is helpful for people to get a sense of what we're actually looking at, and is also used for test cases. So running the tests, the regexes across the examples serves as a sort of test as well. So I don't know how familiar any or all of you are with regexes, but you can see at the top here, the fingerprint pattern equals, and then we have in quotes, this is the regular expression. So needs to begin with the string pro FTPD, and then it's in the brackets, it's capturing the version information. So it's like numbers followed by non-white space, and then we've got server, and then has to say Linksys, and then we know that it's this particular wireless access point. So we have the parameters there, which refer back to the capturing groups in the regex. So where it says pause equals 0, that just means we positively identify this. We know that it's pro FTPD, so we just say that. We're not using any of the information that we've captured out of the capturing groups, sorry, and that it's a Linksys wireless access point. But the parts that vary, we have the position equals 1 for the version, and then for the actual OS, product, and host name are the other two positions, the capturing groups here. So this is helpful if you have a device on your network that could be showing up just as Linux based on IP stack fingerprinting or something like that. Maybe it'll just say unknown. So we want to move past that and get more useful information. So great, yeah. So I can't take credit for all this clip art, but yeah, great. So what now? Just go through a quick example here. Again, this was originally done by someone who isn't me. I would have done my own home network recog discovery project specifically for this talk, but I'm still evaluating the best options for my future home theater PC solution. I don't actually have that many interesting devices hanging out on my home network. But this QNAP NAS here, it runs a RAID 1 file server, and big network stack, all sorts of stuff on there. You can see this is a screenshot from an expose scan showing all the services that are available there and how it's been fingerprinted. So it's like Apple, Bonjour, the NFS. It's got a built-in web server and more and more stuff. So it's fingerprinting this as like Linux 2.4, which is probably not actually the case. It's kind of old for a device running all the different services that this thing is. So the IP stack analysis is not always that reliable. And in particular here, we can see port 49152 at the bottom. This is fingerprinted as HTTP, but has a Linux 2.6 banner. So what's actually going on here doesn't really make much sense. It's bad results. It's not precise. It's not accurate. So it's a UPnP fail. Here's some more human-readable version of the Nexpose log file from that scan. So it's HTTP isn't strictly wrong. It's UPnP running over HTTP, but we can be a lot more accurate than this. So we've logged the fact that it's Linux 2.6 UPnP 1.0. We've got more information here, so it's not matching against what it found. At the very least, we should be able to call it UPnP instead of HTTP, right? And we could also do better on the OS fingerprint here. So yeah, again, not precise. So here's another fingerprint example from Recog. So the original intent of this example was to find something to actually add to the project and go through that, but it turns out it was already in there. But the idea is that you could be scanning your own networks, your own assets, and if the fingerprinting is not there, not reliable, not showing you what it could be, you can write one of these fingerprints and have that available. So yeah, this is just, I'm not going to go through another example of the fingerprint since it's more or less the same idea as the last one, right? It's just running a regex against the banner that it pulls and the examples for what this is supposed to actually look like when you see it, and pulling out the relevant data in a more structured way. So here's the Nexpose scan again, but with the Recog fingerprints backing it. And you can see that there's the new OS fingerprint. It's Linux 2.6, which is more likely based on what else the machine is running there. And better fingerprinting of port 49152. It's got UPnP on there and a version of libpnp. So this gives you better vulnerability identification, right, and correlation with other devices or services on your network, better knowledge and understanding of your network topology. And something like this comes up, you see it on a scan. It's UPnP, this is bad news. You don't want something like this on your perimeter of your network, right? So before it's like HTTP, whatever, but here you're like, okay, make sure that is, off limits to the outer world. So yeah, again, you can contribute back to this. There's a GitHub project. If you've got devices that Metasploit or Nexpose doesn't recognize, or worse, it recognizes it but is completely wrong, which is known to happen, grab a banner and it's not that hard to create one of these fingerprint files and contribute it back, and then everyone in the community benefits. So although Nexpose and Metasploit use this, it's not directly tied to it. It's meant to be agnostic to whatever projects want to make use of it. So yeah, and the data is there. You can take it and do what you want with it. So you know, GitHub basics. The idea is just clone it, you know, fork it. It depends on Ruby 1.9.3, which is not that new. So hopefully, you know, reasonable requirement for most people. And yeah, there's you know, the example tags you can put right in the fingerprint are a nice way to have super easy unit tests for them as well. And so finally, there's some of the people that have worked on this, H.D. Moore, John Hart, other Rapid7 Labs people, and the Nexpose team, Metasploit, and mostly Rapid7. And also thanks to Ross and Ryan for this deck that I didn't have to create myself. And that's all I've got. It looks like we're at the 20-minute mark. If there's any questions, I'd be happy to take them. And if there's not, I would be happy to not take them as well. All right.